What would happen if an object from the depths of interstellar space, a traveler that has crossed distances our minds can barely conceive, suddenly changed its course in the void, as if someone, or something, had decided to correct its destiny? Stay with me until the end, because what you are about to hear tonight could change the way you look at the night sky. This story begins in the Nevada desert, where a NASA telescope captured something no one expected to see.
Friends, I'm Felipe Suarez, and tonight I want you to get comfortable because the universe has just sent us a very strange message. Have you ever thrown a stone toward a lake and expected it to change direction mid-flight? Sounds impossible, right? Well, that is exactly what an interstellar comet called 3I Atlas appears to have done. Cosmic coincidence or something deeper? Listen carefully.
In recent weeks, the international scientific community has experienced a state close to collective astonishment. A celestial object, officially catalogued as 3I Atlas, has become the center of attention of observatories distributed across the entire planet. This is not an ordinary comet, one of those that appear periodically in our skies and that astronomers can predict decades in advance. This one is different. This one is an intruder, a visitor that comes from somewhere beyond the confines of our solar system, from regions so distant that light would take years, perhaps centuries, to travel that journey. What makes 3I Atlas special is not only its interstellar origin. After all, we had already received visitors of this type before. In 2017, an object called Oumuamua passed through our cosmic neighborhood, leaving scientists with more questions than answers. But 3I Atlas is doing something no one anticipated, something that defies the physical models we have built over decades of observation and study. The first signs that something unusual was occurring came from an unexpected place. In the heart of the Nevada desert, where the night sky remains dark and crystalline, free from the light pollution that affects so many other regions of the world, a telescope operated in collaboration with NASA captured images that left researchers perplexed. The comet's trajectory, according to the most recent calculations, had experienced an adjustment. Not a random push caused by solar wind, not a chaotic perturbation resulting from the typical outgassing of these icy objects, but a precise, almost surgical change that placed it on a completely different route from the one initially projected. And this is where the story becomes truly intriguing, because that adjustment, that course correction that the instruments detected, did not occur when the comet was visible from Earth. It happened when 3I Atlas was behind the sun, hidden from our telescopes, invisible to any terrestrial observatory. When it finally reappeared in our field of vision and astronomers updated their orbital calculations, they discovered that something, whatever it may have been, had pushed the comet just enough to alter its destiny. The magnitude of that change is not trivial. The data indicate that 3I Atlas is now heading toward a specific region of space near the Moon, a trajectory that, according to previous models, it should not have followed. It is as if an arrow shot toward a target had decided, mid-flight, to change objectives. And when scientists calculated the probabilities of this happening by mere chance, the numbers turned out to be astronomically low. The Nevada telescope, with its capacity to capture high-resolution images even under difficult observation conditions, has provided some of the most detailed photographs of this enigmatic visitor. In those images, researchers have been able to observe characteristics that add additional layers of mystery to this cosmic puzzle. The structure of the comet, the way its tail extends into space, the brightness patterns it exhibits. Everything seems to defy conventional expectations.
Do you realize what this means, friends? A comet that changes course when no one was watching. Has it ever happened to you that you left something in one place and when you returned it was no longer where you remembered it? Well, imagine that, but on a cosmic scale. What natural force can produce that level of precision? Or are we perhaps facing something that our physics books still cannot explain?
To understand the magnitude of what is occurring, it is necessary to understand some fundamental concepts about how comets behave in space. These objects, composed mainly of ice, dust, and volatile compounds, develop distinctive characteristics when they approach the Sun. Solar radiation heats their surface, causing the ices to sublimate directly into a gaseous state, releasing jets of material that form the famous cometary tails that have fascinated humanity since time immemorial. Those gas jets, known as outgassing processes, act like small rocket engines, pushing the comet in directions that sometimes prove unpredictable. It is a well-documented phenomenon, observed in dozens of comets over the years, and it is the first explanation scientists seek when a cometary object shows changes in its trajectory. But here is the problem with 3I Atlas. Outgassing produces chaotic, erratic pushes, not adjustments of millimetric precision. It is like trying to park a car by blowing on it with a fan. You could move it, yes, but you would never manage to place it perfectly in the designated space, with the tires aligned exactly on the parking lines. And yet, that is precisely what appears to have happened with this interstellar comet. The push it experienced was of the exact magnitude, at the exact moment, to place it on a trajectory that will culminate with a significant approach to the lunar orbit. The astronomers working with the data from the Nevada telescope have spent weeks analyzing the images, searching for some conventional explanation that could account for this anomalous behavior. They have reviewed the outgassing models. They have considered possible gravitational interactions with undetected objects. They have explored the possibility that the comet's chemical composition is so exotic that it produces effects our current models cannot predict. But so far, none of those explanations fits perfectly with all the observations. What makes this situation even more disconcerting is the direction of the course change. 3I Atlas did not deviate toward any random point in space. It deviated toward our moon, toward the natural satellite that has accompanied Earth for billions of years, toward a target that, from any reasonable perspective, seems too specific to be the product of chance. The captured images reveal additional details that intensify the mystery. The comet exhibits an unusual tail structure, with characteristics that very few objects of this type have shown before. In addition to the main tail, which extends in the direction opposite to the Sun as expected, 3I Atlas presents what astronomers call an anti-tail, a formation that seems to point toward our star instead of away from it. This phenomenon, although rare, is not completely unknown in cometary science. It occurs when heavier dust particles remain suspended along the comet's orbit, and from certain observation angles, they appear to form a tail that defies physical logic. It is essentially a perspective effect, an optical illusion caused by our position relative to the object. But the anti-tail of 3I Atlas has characteristics that do not fit with this simple explanation. It is too narrow, too defined, too stable. In the photographs from the Nevada telescope, it appears as an almost perfectly straight line, traced across millions of kilometers of empty space, with a precision that is more reminiscent of a laser beam than a natural dispersion of cometary particles. And that, according to the physical models we have, should not be possible.
Friends, I am going to confess something to you. When I first saw the images of that anti-tail, I felt a chill run down my spine. Have you ever had that feeling that something does not fit, that there is a piece of the puzzle missing? I have, and I think many scientists are feeling exactly the same thing right now. What force can keep particles in formation across such enormous distances?
When a comet releases dust into space, that material should gradually disperse. The Sun's gravity, the pressure of solar radiation, the small gravitational perturbations caused by the planets, everything contributes to the particles spreading in broad and diffuse patterns over time. It is a predictable process, mathematically modeled with great precision, and consistently observed in practically all the comets we have studied throughout the history of modern astronomy. But the anti-tail of 3I Atlas does not behave this way. The particles that compose it seem to maintain an ordered formation, as if something were guiding them, as if there existed an invisible force keeping them aligned against all physical expectations. Researchers have proposed several theories to explain this phenomenon. Perhaps the comet's chemical composition includes materials we have never found in objects from our own solar system. Perhaps there are electromagnetic fields involved, complex interactions between the cometary dust and the solar wind that our current models do not adequately capture. Another possibility is that the internal structure of the comet's nucleus is so irregular, so different from what we are accustomed to seeing, that it produces perfectly directed gas jets, creating patterns that appear artificial, but are actually the result of natural processes we simply do not understand yet. All of these are scientifically valid explanations, and the research teams are working day and night to evaluate them. However, there is a persistent problem. Every time scientists believe they have found an answer, a new observational detail appears that does not fit with the proposed theory. It is like trying to assemble a puzzle where the pieces change shape every time you look at them closely. And that frustration, that sensation of always being one step from comprehension but never quite reaching it, is generating an increasingly intense debate within the astronomical community. Professor Abraham Loeb from Harvard University has been one of the most prominent voices in this debate. This is not a marginal theorist or an amateur enthusiast. Loeb is a scientist with decades of experience, hundreds of publications in high-impact specialized journals, and an established reputation as one of the most brilliant astrophysicists of his generation. For almost a decade, he directed Harvard's Astronomy department, a position that requires not only academic excellence, but also the respect of his peers. And Loeb has suggested something that makes many of his colleagues feel profoundly uncomfortable. He has proposed that objects like 3I Atlas, and before it Oumuamua, might not be completely natural. He is not claiming they are alien spacecraft piloted by little grey beings. He is not proposing an imminent extraterrestrial invasion. What he is saying is much more nuanced, and perhaps for that very reason, more unsettling. Loeb argues that the anomalies we are observing are so significant, so difficult to explain with known physics, that it would be scientifically irresponsible not to consider all possibilities, including those we have traditionally dismissed as science fiction. For him, maintaining a closed mind in the face of evidence simply because certain explanations make us uncomfortable is not doing science. It is doing the opposite.
Can you believe that a Harvard scientist is saying these things publicly? Not a conspiracy theorist, not an amateur with a telescope in his backyard, but someone who directed one of the most prestigious astronomy departments in the world. What does that tell us about the current state of our knowledge? Are we closer to the answers or further away than we thought?
The implications of what Loeb and other scientists are suggesting are profound. If we accept, even as a working hypothesis, that some interstellar objects might have a not completely natural origin, then we must rethink our position in the cosmos in ways that are dizzying. We would no longer be passive observers of an indifferent universe, but possible participants in a much larger story. A story that could include other civilizations, other intelligences, other travelers of the interstellar void. But before we let ourselves be carried away by speculation, it is important to remember that science operates on the basis of evidence. And so far, although the anomalies are genuine and disconcerting, we do not have definitive proof that 3I Atlas is anything more than an extraordinarily unusual natural object. What we have are questions, many questions, and the determination to find answers through meticulous observation and rigorous analysis. The Nevada telescope continues to track the comet every night that atmospheric conditions permit. Each new image is analyzed with exhaustive detail. Each measurement is compared with existing models. Each discrepancy is documented and studied. It is a slow, patient process, requiring discipline and humility. The scientists know that answers will not come overnight, but they also know that each piece of data collected brings them a little closer to the truth. One of the most intriguing characteristics revealed by recent observations is the variability of the comet's brightness. 3I Atlas does not shine constantly. Its luminosity fluctuates in patterns that do not correlate perfectly with the expected rotation of its nucleus. There are moments when it becomes significantly brighter, as if it were releasing large quantities of material suddenly, and other moments when its brightness decreases in ways the models cannot predict. These variations could indicate that the comet's surface has active and inactive regions, areas where the ices evaporate easily, alternating with more stable zones. Or they could suggest that the nucleus has an extremely irregular shape, perhaps elongated like Oumuamua, which produces dramatic brightness changes as different surfaces become exposed to the sun. Or they could be signs of something we have not yet considered. What is particularly fascinating is the rapidity with which some of these changes occur. In traditional cometary astronomy, brightness variations usually develop over days or weeks, following predictable patterns related to distance from the Sun and orbital geometry. But with 3I Atlas, significant changes have been observed in much shorter periods, sometimes in a matter of hours. It is as if the comet were responding to stimuli we cannot detect, reacting to signals invisible to our instruments.
Friends, imagine for a moment that you are watching a movie and suddenly the main character does something completely unexpected, something that makes no sense according to the plot you had been following. What would you think? That the screenwriter made a mistake, or that there is something in the story you are not seeing yet? That is exactly what scientists feel now with 3I Atlas. Is there something we are missing?
Observations from Nevada have also revealed fine structures within the comet's tails that suggest multiple emission sources active simultaneously. Instead of a single jet of material emanating from the nucleus, there appear to be several points of origin, each releasing gas and dust in slightly different directions. This creates a complex pattern, almost as if the comet had several small geysers functioning at the same time, each with its own dynamics and its own rhythm. This multiplicity of sources could partially explain some of the observed anomalies. If different regions of the nucleus are releasing material with different chemical compositions and at different times, the result could be a collective behavior that seems chaotic, but that actually follows rules we simply have not identified yet. It is a possibility that researchers are actively exploring, constructing computational models that attempt to reproduce the observations from first physical principles. But even if we manage to explain the tail structure and brightness variations with these models, we still have the fundamental problem of the trajectory deviation. We still have to explain how a natural object could adjust its course with such precision while hidden behind the sun, emerging on a route that brings it significantly closer to the moon. And that, frankly, is the part of the mystery most difficult to accept from a purely physical perspective. The calculations performed by several independent research teams agree on a crucial point. The probabilities that the observed deviation is the product of chance are extraordinarily low. We are talking about figures that make even experienced statisticians raise their eyebrows, numbers that suggest that if this was a coincidence, it was one of the most improbable coincidences in the history of astronomical observation. The next important milestone in the trajectory of 3I Atlas will be its close pass by the lunar orbit, an event that scientists await with a mixture of anticipation and anxiety. During that encounter, we will have the opportunity to observe how the comet reacts to a different gravitational environment, how it interacts with Earth's magnetic field, what changes it experiences in its activity and structure. It will be an invaluable window into the true nature of this mysterious visitor. But it will also be a moment of testing for our theories. If the predictions based on conventional physics are fulfilled, if the comet's behavior during the lunar approach can be completely explained with our current models, then we will have evidence that the previous anomalies, as disconcerting as they may seem, are the result of natural processes we simply did not understand well. On the other hand, if new anomalies arise, if the comet once again defies our expectations in unexpected ways, then we will have to seriously reconsider what is happening with this object.
What will happen when 3I Atlas reaches near the moon? That is the question we are all asking ourselves. Will it be a calm encounter that finally gives us the answers we seek, or will it leave us with even more questions? Friends, I confess to you that I cannot stop thinking about this. What do you believe? Is the universe preparing a surprise for us?
The participation of the Nevada telescope in this investigation represents an important chapter in the history of American astronomy. This instrument, originally designed for the detection of potentially hazardous asteroids, has demonstrated its versatility by contributing significantly to the study of an object no one anticipated. Its location in the desert, far from the lights of large cities, grants it observational advantages that few other observatories can match. The nights in the Nevada desert are extraordinarily dark. The atmosphere, dry and stable, allows obtaining images of exceptional clarity. And the team of astronomers operating the telescope has demonstrated admirable dedication, working extended shifts to capture every possible moment of observation. They know that this opportunity is unique, that interstellar visitors do not pass through our solar system frequently, and that each piece of data collected could be crucial for unraveling the mystery. International collaboration has also played a fundamental role in this effort. Observatories in Chile, in Hawaii, in Europe, in Australia, all have pointed their instruments toward 3I Atlas, contributing data that complements the observations from Nevada. It is a beautiful example of how science transcends borders, of how shared curiosity can unite people from different countries and cultures in a common search for knowledge. The data collected from different parts of the world allow constructing a more complete picture of the comet. Each telescope observes from a slightly different angle. Each instrument has unique sensitivities to different wavelengths of light. Each research team contributes distinct perspectives and methodologies. When all that data is combined, patterns emerge that no individual observatory could have detected on its own. One of the most important contributions of this global collaboration has been the precise determination of the comet's orbit. Combining observations from multiple terrestrial locations allows triangulating the object's position with extraordinary accuracy, reducing the uncertainties in orbital calculations to minimal levels. And that precision is crucial, because only with high-quality orbital data can we be certain that the observed deviation is real and not an artifact of measurement errors. The results of this collaborative analysis are unequivocal. The trajectory deviation of 3I Atlas is genuine. It is not an instrumental error. It is not a consequence of incomplete data. It is not an illusion caused by observational geometry. The comet really changed its course while hidden behind the sun, and now it is heading toward a close encounter with the orbit of our natural satellite.
Friends, there is something profoundly moving about seeing scientists from all over the world working together to solve this mystery. On a planet that sometimes seems so divided, the cosmos reminds us that we all look toward the same stars. Does that not seem to you to say something important about who we are as a species? About what we can achieve when we set aside our differences?
The story of 3I Atlas cannot be told without mentioning its predecessor, the enigmatic Oumuamua. When this object was detected in October of 2017 by the Pan-STARRS telescope in Hawaii, it marked a historic moment in astronomy. It was the first time we observed an object that undoubtedly came from outside our solar system, a genuine visitor from interstellar space. The name Oumuamua, which in Hawaiian means approximately messenger from afar arriving first, proved prophetic in ways no one anticipated. Because Oumuamua was indeed a messenger, although the message it brought was one of confusion more than clarity. Its shape was extraordinarily unusual, elongated like a cigar, perhaps 10 times longer than wide. It showed no visible tail despite passing relatively close to the sun. And most disconcerting of all, it accelerated while moving away from our star, as if something were pushing it from behind. Astronomers proposed multiple explanations for this anomalous acceleration: outgassing of exotic ices that did not produce a visible tail, solar radiation pressure acting on an unusually reflective and thin surface, thermal effects no one had previously considered. But none of these theories fit perfectly with all the available observations. And before we could study the object in greater detail, it disappeared into the darkness of interstellar space, moving away too fast for our telescopes to follow it. Oumuamua left us with a bittersweet taste. On one hand, it had demonstrated that interstellar visitors exist, that the space between stars is not empty, but populated by objects that travel through it for millions, perhaps billions of years. On the other hand, its fleeting passage had denied us the opportunity to answer the most important questions it raised. It was like having received a letter in an unknown language, knowing it contained an important message, but being unable to decipher it. And now, years later, 3I Atlas has arrived. Another interstellar visitor, another object that defies our expectations, but this time with a crucial difference. This comet is more active than Oumuamua, brighter, easier to study, and most importantly, it is not moving away yet. We have months, perhaps years, to observe it before it disappears into the depths of space.
Do you realize the opportunity we have before us? Oumuamua slipped through our hands, literally, but 3I Atlas is still here. We can still study it. We can still try to understand it. How many times in life does the universe give us a second chance? Because that is exactly what this seems to be, friends.
The similarities between Oumuamua and 3I Atlas are as notable as their differences. Both are genuine interstellar objects. Both show behaviors that defy conventional explanations. Both have generated intense debates within the scientific community. But while Oumuamua was dark and silent, almost invisible if not for its movement against the background of stars, 3I Atlas is bright and active, displaying spectacular tales and exhibiting a dynamic that fascinates observers around the world. There are those who see in these similarities the suggestion of a pattern. If two consecutive interstellar visitors show significant anomalies, they argue, perhaps that tells us something about the nature of these objects in general. Perhaps the processes that form interstellar objects produce characteristics that are fundamentally different from what we see in the comets and asteroids of our own solar system. Perhaps there is something in the conditions of interstellar space, that cold and dark void between the stars, that transforms objects traveling through it in ways we do not yet understand. This is a scientifically reasonable hypothesis, and it is being actively explored by several research groups. If interstellar objects are systematically different from local objects, then the anomalies of Oumuamua and 3I Atlas would not be inexplicable mysteries, but the first clues toward a new understanding of the physics of deep space. But there is also another possibility, one that Abraham Loeb and others have raised with increasing insistence. What if the similarities between these two visitors are not the result of common natural processes, but of something more deliberate? What if there is a reason why both objects show such unusual characteristics? What if we are seeing evidence of something we would prefer not to consider? It is important to emphasize that these are questions, not assertions. No one is saying with certainty that 3I Atlas or Oumuamua are artificial. What is being said is that the anomalies are significant enough that we should maintain an open mind, that we should not dismiss possibilities simply because they make us uncomfortable.
Friends, I want you to think about something. If 100 years ago someone had said that telephones would allow us to see people on the other side of the world in real time, they would have been called crazy. How many things we consider impossible today will be routine for our grandchildren? Should we not be more humble about the limits of our knowledge?
The following weeks will be crucial for our understanding of 3I Atlas. As the comet continues its journey through the inner solar system, telescopes around the world will continue tracking it with meticulous attention. Each observation, each measurement, each captured image will add information to our collective understanding of this extraordinary visitor. The Nevada telescope, in particular, will continue to play a central role in this effort. Its technical capabilities, combined with the experience of its operating team, make it an invaluable instrument for this type of research. And the data it is generating, are not only useful for the study of 3I Atlas, but are also laying the groundwork for future observations of interstellar objects that will inevitably arrive in the years and decades to come. Because one of the most important lessons of this story is that interstellar visitors, far from being isolated rarities, are probably much more common than we thought. Before the detection of Oumuamua, some astronomers estimated that perhaps a single interstellar object might pass through the inner solar system approximately every decade. But the fact that we have detected two in so few years suggests that space is more populated with these travelers than our models predicted. If that is true, then 3I Atlas will not be the last mystery of this type we face. Others will come, perhaps soon, perhaps with anomalies even more pronounced than those we are observing now. And when they arrive, we will be better prepared to study them, thanks to what we are learning from this current visitor. The images from the Nevada telescope show a constant evolution in the comet's appearance. The tails change shape almost daily, developing new structures, dissolving others, in a cosmic dance that reflects the dynamic interaction between cometary material and the solar wind. There are moments when the anti-tail intensifies dramatically, becoming brighter and more defined, and others when it seems to fade almost completely. The researchers are documenting each of these changes with obsessive detail, constructing a temporal record that will allow future analyses long after 3I Atlas has left our cosmic neighborhood. It is tedious but essential work, the type of meticulous science that rarely appears in headlines, but that constitutes the foundation upon which great discoveries are built.
Do you know what I find beautiful about all this, friends? That there are people right now, while you listen to these words, who are looking toward the night sky, capturing light that has traveled from unimaginable distances. Does that not give you hope? Does it not make you feel that human curiosity is one of our best qualities?
Among the most fascinating aspects of recent observations is the distribution of dust in the vicinity of the comet. In a typical cometary object, we would expect to see a clear separation between fine particles and coarse particles. Fine dust, being lighter, is quickly pushed away from the nucleus by the pressure of solar radiation, forming the classic tail that extends in the direction opposite to the sun. Coarse dust, being heavier and therefore less affected by radiation, remains closer to the comet's orbital path, forming different structures. Over time, this separation becomes increasingly evident in conventional comets. We can clearly see where the domain of fine dust ends and the zone where heavier particles predominate begins. It is a predictable pattern, observed again and again in decades of cometary study, and it allows us to infer information about the composition and internal structure of the nucleus. But in 3I Atlas, this separation is not as clear as it should be. There are regions where fine and coarse dust appear mixed in ways that do not fit our models. It is as if the particles had been released from the same regions of the nucleus at the same time, but then behaved in fundamentally different ways, defying expectations based on simple physics. Researchers have proposed several hypotheses to explain this anomaly. Perhaps the comet's chemical composition includes materials with unusual optical properties, which reflect light in ways that confuse our measurements of particle size. Perhaps there are electromagnetic interactions at play, forces acting on the dust particles beyond simple radiation pressure and gravity. Perhaps the geometry of the emission is so complex, with multiple sources active simultaneously, that the result seems chaotic, although it actually follows rules we simply have not identified. All of these are scientifically valid possibilities, and each is being investigated with rigor. But so far, none has managed to completely explain all the observational data. It is a frustrating but also exciting situation, the type of intellectual challenge that drives scientists to think in new and creative ways. The chemical composition of 3I Atlas remains largely unknown. Spectrographs, those instruments that decompose light into its component colors to reveal the chemical signature of the emitting materials, have detected some familiar signals. There is evidence of water, of carbon dioxide, of simple organic compounds. But there are also signals that do not fit neatly into any known category, hints of materials that could be genuinely exotic.
Does it not seem incredible to you that a piece of rock and ice, traveling from who knows where, can teach us so much about ourselves, about our capacity for wonder, our determination to understand, our humility in the face of the unknown? Friends, I think that says a lot about what it means to be human.
As this story continues to develop, there are lessons we can already extract from what we have observed so far. 3i Atlas has taught us that the universe is capable of surprising us even after centuries of observation and study. It has shown us that our models, however sophisticated they may be, still have significant limitations. It has reminded us that the frontier between the known and the unknown is much thinner than we would like to admit. But perhaps the most important lesson is about ourselves, about our capacity to maintain an open mind, to consider possibilities that make us uncomfortable, to accept that we do not have all the answers. The history of science is full of moments where disconcerting anomalies turned out to be the doors toward new paradigms of understanding. Perhaps 3i Atlas represents another of those moments, or perhaps when all is said and done, we will discover that there was a perfectly reasonable natural explanation for every anomaly observed, that the trajectory deviations, the unusual tail structures, the unexplained brightness variations, all were the result of ordinary physical processes acting in ways we simply had not anticipated. And that too would be a valuable discovery, because it would teach us that nature is even more ingenious and complex than we thought. Either way, we are living an extraordinary moment in the history of astronomy, a moment in which the universe is showing us something new, something we did not expect, something that challenges us to think more deeply and to observe more carefully. And that, ultimately, is what science is about. Not having all the answers, but asking better questions. The Nevada telescope will continue pointing toward the stars night after night, capturing light that has traveled from unimaginable distances. Scientists will continue analyzing data, debating theories, publishing articles that will be read and criticized and improved by their colleagues. And 3i Atlas will continue on its way, indifferent to all that activity, following the trajectory that gravity and perhaps other forces have imposed upon it. Eventually, the comet will move away too far to be observed. Its light will gradually fade until it becomes indistinguishable from the dark background of space. And we will be left with the data we have collected, with the theories we have developed, with the questions we may never be able to answer completely.
Friends, I am Felipe Suarez, and before saying goodbye, I want to ask you something from the heart. If this story made you think, if it made you look upward with new eyes, if it awakened even a spark of that curiosity we all carry inside, I invite you to subscribe. There are many more stories waiting to be told.